Gravity is a fundamental force that exists everywhere in the universe, and its effects are present in all regions. However, the strength of gravity can vary depending on factors such as the mass of objects and their distances from each other. In any case, there isn't a place where gravity completely does not work. There are, however, environments where the effects of gravity might be less noticeable or where objects may appear to experience reduced gravity due to specific conditions. For example, microgravity environments, such as those experienced by astronauts in space or during freefall in an aircraft. Inside a freely falling object, when an object is in freefall, its occupants experience apparent weightlessness, as demonstrated in zero-gravity airplane flights. Neutral buoyancy pools, large pools used for astronaut training where buoyancy counteracts the effects of gravity. Balloon in the upper atmosphere. At higher altitudes, the effects of gravity are slightly weaker. Space stations. Objects within space stations experience microgravity due to the continuous freefall around the Earth. Lagrangian points. Specific points in space where the gravitational forces of two large bodies, such as the Earth and the Moon, create regions of stable equilibrium. Outer space. In deep space, far from any massive objects, gravity is extremely weak, but it is not absent. Geostationary orbit. Objects in geostationary orbit appear to be stationary relative to the Earth's surface, but gravity still acts on them. Inside an accelerating spaceship. In a spaceship that is accelerating at a rate equal to the acceleration due to gravity, occupants would feel a simulated gravity, but it would not be due to gravitational forces. Rotating space habitats. In a rotating space station, centrifugal force can simulate gravity on the inner surface. High-altitude balloons. Objects at high altitudes experience slightly weaker gravity than those at the Earth's surface. Reduced gravity aircraft. Aircraft flying parabolic trajectories can create short periods of microgravity. Theoretical wormholes. While purely theoretical, if traversable wormholes exist, they could provide a pathway where gravitational forces might act differently. Centrifuges. In a centrifuge, the apparent gravity can be increased or decreased depending on the rotational speed. Black holes. While not a place where gravity does not work, the extreme gravitational forces near a black hole can cause unusual effects on space and time. It's important to note that even in these environments, gravity is still at play, but its effects may be lessened, simulated, or counteracted by other forces. Gravity, a fundamental force in the universe, is the invisible glue that holds everything together. It is the force that makes apples fall from trees, keeps our feet firmly on the ground, and holds the planets in their orbits around the sun. In essence, gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. It is mathematically described as the force between two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. But let's not get lost in the numbers. What's really fascinating is how gravity shapes our world. It defines the weight of objects on Earth, influences the growth of plants and animals, and even affects the movement of the oceans. Without gravity, there would be no life as we know it. But what if we told you there are places on Earth where gravity appears to defy its own rules? Yes, you heard right. There are certain areas on our planet where the gravitational pull is less than in other places. This results in a strange phenomenon known as a gravity hill or magnetic hill, where objects seem to roll uphill instead of downhill. It's a sight that baffles the mind and challenges our understanding of gravity. In addition to gravity hills, there are other intriguing anomalies across the globe. The Hudson Bay area in Canada, for instance, has lower gravity than other regions. This anomaly is due to the massive ice sheets that once covered the area during the last ice age. The weight of the ice compressed the Earth's crust, and even though the ice has long since melted, the crust is still rebounding, resulting in a lower gravitational force.